for which it stands, one nation, under God, indivisible, with liberty and justice for all. All right. Any first-time visitors here with us today? First time you've joined us at a club meeting, either virtually or in person. I think I recognize. Oh, there we go. John, go ahead and introduce yourself. Where are you from? You're muted, John.
You talking to me?
No.
Yeah.
No, too many Johns.
WB6MEI. There you
go.
go.
I was looking at N7MM.
Yeah.
Oh, okay.
Hi, guys. I live in west of Valley Center. Been here for about 30 years, and been a member in the past. And I'm thinking of joining again, but I'm either going to join again or move to Texas. That's my decision.
Well, this is Mark, and I live in West Valley Center.
Okay.
So
I live off of West Lilac Road, overlooking Lilac Ranch to the east of me, and I'm the pink house on the top of the hill on Valley Grove Lane. So,
well, I live. You know where the little market and liquor store and stuff is? I live up on the hill above that on West Lilac, or on regular Lilac.
Okay, well, you're about 6 miles away, I think, somewhere around there.
Yeah.
Okay,
I'm in the middle of I'm in the middle of town.
Oh, okay. No, I'm not even officially in Valley Center. My address is in Escondido, and Valley Center wants to annex us, and I'm not sure I want to be annexed. I like just living out here by myself. So.
Yeah, same here. But I kid about the middle of town because Valley Center, well, they're trying to build a middle of town. Thank God they're not building it near me.
All right. Well, welcome. Any other first-time visitors?
XE2/NA6MB.
XE2/K6GO.
If only.
From out of country.
If only we could get licensed down here.
Yep.
It's a mess.
All right. Anybody else? No? Okay. Let's see. Announcements. Hey, Joe, Ashley, do you happen to have anything on testing for us? Any news with things starting to open back up? Or is it still just Glarg?
No, things are starting to happen. Sandock is going to do online testing. And
Great.
even the in-person testing, they're going to be using the exam tools program the same as the online testing. So things are starting to happen. We have no fixed date yet for first time.
Okay.
We will be.
Fantastic. Info on that on the Sandark website, I assume?
I don't know if anything's up there yet. They're still talking a lot between Greg and the Sandark board, and explaining the program and all this stuff. So things are moving in the right direction.
More info to come. Great.
Yeah, I'm sure it'll be up there on the website as soon as decisions are made.
Okay, great. Thanks for that. Kevin, anything on scouting that we can that the club can help support?
Thank you for asking. The next event that we're trying to do is get our radio set up, HF and 2 meter 440, at Fiesta Island, the scout location in Fiesta Island. It turns out that the host is a ham radio operator, extra class, and the final dates and the like haven't been complete yet, in part because we are subject to the shifts of COVID protocol. But there's every intent to have a safe in-person scout program this summer at Fiesta Island. Next big event after that, of course, is Jamboree on the Air, the third week in October, and we are beginning to prepare for that to coincide with Weeblos Woods, which is the same weekend. So if all goes well with the COVID protocol, we'll have Weeblos Woods with an amateur radio presence and Jamboree on the Air, at Mattagway and a Jamboree on the Air at Camp Balboa. This is again in the third weekend in October. I think this is the 62nd or 63rd Jamboree on the Air. So stay tuned. More later. Thanks a bunch.
Great. Fantastic. Yeah, keep your eyes open for more of those. Any of that stuff that you need published, Kevin, go ahead and send it to scope@palomararca.org so we can help get the word out and get people on the air.
Will do. Thanks.
All right. Any other announcements that anybody has that they feel the group would be benefited by hearing?
I can give an update on our buoy project. It's
All right,
continuing
sure,
to
Phil.
work just fine. Yeah, look for KQ6 Quebec. Kilo Quebec 2 Romeo Sierra -2 on APRS. That's a buoy that Randy has built, and we had launched on the 18th of March, I believe. It is still operating normally. The last time we did this back in July, it only ran for a week, but we've redesigned the antenna and beefed it up quite a bit. So it's still live. It's following the California current. Eventually, it should hit the North equatorial current and turn to the west, and seems to be doing that right now. It was taking a beeline for Guadalupe Island. We were afraid it was going to hit Guadalupe Island. You know, the Mount Carmel Radio Club, Amateur Radio Club, has been launching a lot of balloons, many of which end up in Salton Sea. So it seemed only natural that if we launched a buoy into the vast Pacific Ocean, it would hit about the only island around. But it looks like it's not doing that. It's steered a nice circular course around there. And so far, so good. We expect the batteries to last for 6 months. It's transmitting Whisper on 20 meters. And I encourage people to go listen for it. It's too close right now to be heard directly on 20 meters. The skip is too long. But you can track it on either whispernet.org or on aprs.fi. The call sign again is Randy Stanky's call sign KQ6RS and /2. That's it.
All right, great. Thanks, Phil.
So one of these years we'll get him to give a talk on this.
Yeah, that'd be really interesting. Okay. Anything else? All right. Mark, do you want to say anything, or you want to keep your stuff for the big presentation? Repeater.
Well, I guess we can give the report. Glenn and I went up on the mountain to put up a mount on the back of the battery building for the new internet that we're going to be putting up. It was supposed to be done yesterday, but Valley Center Wireless had some huge server problems. So they asked if they could do it maybe Friday. And I told them, yep, that's fine with me. We'll go up and mount the dish and the LNB on Friday, hopefully, provided they get their server problem straightened out. We also noted, and it's in the presentation, that we broke a mast, and we've got a Yagi laying against the side of one of the buildings where the mast snapped off during the last storm. It appears like it loaded up with ice, and then the winds came up, and that storm we had and did it in. Fortunately, the good news is it was an antenna that's no longer in use. The bad news is it's a really nice antenna. So we're looking at putting it up and repurposing it for something else. For example, Phil, it's a nice 2-meter antenna that's not tied to anything. We could hook it to SDRs.
Okay.
Anyway, other than that, everything's up and running. 6-meter is still a little iffy, but that's to be worked on.
Okay.
It works. It's just really noisy.
All right. Thanks for that, Mark. Glenn, membership?
Well, I think last meeting we were down to 157 members. We're now down to 152, and I've got several, I think 5, maybe 6 updates I need to do to the database. So they may raise that back up to 158 maybe. And The only thing I guess I've thought a number of times lately about as membership chair, and I was going to write this for the scope and didn't get anything in there, so expect it next month, is I'd like to see us at Charlie's, with Charlie pushing on it, and it makes a lot of sense, is come up with some way to connect the expertise that we have in the club with ham radio across the spectrum with the newer hams that need that expertise, and propose some ways to hook us together and so that those can happen. And one suggestion in a board meeting recently was that we could as we see YouTube videos that make sense, there's so many YouTube videos, we could be part of the filtering and find the good ones and use and recommend those to the newer club members. And part of my thought now is if they watch a YouTube video and they have questions about it, they could ask the pool of more experienced hams, and we could provide answers to them. So that's kind of, hoping to build the membership back up by making membership to be more active. That's all I got. Thanks.
Okay, great. Well, the next thing on my list is the goodie table, but we're not in person, so there's no goodie table. We are looking at the options for coming back in person. I mentioned that in the scope, and I've gotten some emails about that. A lot of us have gotten vaccines. I myself have gotten my first Moderna. I have my second one coming up in about 14 days, actually. So, that we're coming up to the ability to get back in person. So we're going to strive to figure out a way to continue to engage people electronically who either don't have the means to come out or don't feel safe coming out just yet. We haven't exactly nailed down what that will look like yet. It may be a stream to the website via YouTube, which would be one way. It may be a Zoom call, but again, it'll probably be mostly one way. I'm not sure how much interaction we'll have via Zoom to the live meeting. So that just seems like it would be a little bit problematic. So
yeah, we're going to have to discuss that during the board meeting.
Yep.
You'll notice that board at Palomar Arc has gotten a lot of requests to keep the Zoom meeting going even after we go live again.
Yep.
So I think we need to discuss that.
Yep, we'll be discussing that amongst the board and have information out to the membership. Just wanted to make sure everybody was aware that it is on our radar. Glenn, go ahead.
Yeah, so as far as the goodie table, it came to mind that John Quivinen had posted a number of items that had come from an estate recently, and there may be stuff there. It was published in the scope. Go take a look. There was something in there about 4 DC solid state scopes that might make a good station monitor if someone needs something like that. Just a thought. So check the scope out.
Okay. All right. Great. So with that, the introductions of your board, if there's no more questions, comments from the group. All right. Mark is your repeater and site chair, repeater technical and site chair, KF6WTN, who you heard from. Keith, KM6CXW, is your scope editor. He would love to have articles and content for the scope, your stations, what you've been working on, et cetera, et cetera. Feel free to send those to scope@palomararc.org, and he will get those in there. Director Chris, KD9LF. Director Ron, AJ6FQ. Membership Chair Glenn, who you just heard from, AI6RR. Treasurer Jim, K2VO. Secretary Other Jim, W6TQS. Your Vice President is Charlie NN3V, who would love to hear about program ideas, requests, and suggestions. Send those to board@palomararc.org. or just directly to Charlie if you have his contact info. And then I am your president, Joe K6JPE, and I will now turn the meeting over to Mark KF6WTN to talk about our technology on the mountain if he's not on the phone. I think he's on the phone. He's muted.
I was
There we
trying to
go.
get hold of John Quivinen and get him to come to the meeting. But
I'll give him
you got, okay, yeah, give him a ring. But you got me too quick. All right, well, as you'll notice tonight, not only am I coming to you from the repeater site, but I'm also coming to you from the repeater site during the day, which is a bigger trick. Anyway, so tonight, what I wanted to do is I wanted to make this feel a little bit more like a ham radio club. And so I was going to talk, this is a presentation that I gave 4 years ago for new hams. And I was hoping to, I'm getting all my stuff in order here. So, and I was hoping to get more new hams, but I did, Joe, I did turn on the simulcast on YouTube now.
Okay.
So this is being recorded and maybe it can be used afterward for
Fantastic.
talking to new hams. Okay, so this has two parts. The first part is just introduction to VHF, UHF, handhelds, mobiles, you know, little stuff above 30 megahertz. And then the second part is what are we doing as a club with those expansive, what is it, $30 a year dues? Is that what it is now, Glenn? Oh, Glenn's, he's probably trying to get hold of John. Anyway, with those extensive dues, like 30 bucks a year, I think, or 35, something like that. We actually do quite a bit and we're going to be doing more. So I'm hoping that we can get more people out of this talk. So if you like this, tell your friends, and I'd be happy to give it elsewhere. Okay, so first thing, what we're talking about is above 30 megahertz, which mostly means 2 meter, 440, and this happens to be Yaesu's, actually not their latest offering. This is the FT2, the FTM 400, and the 991 VHF, UHF, although the 991 there on the right is also a full HF rig. And I have all three of those. They work like a champ. Okay, now the next one, I wanted to talk a little bit about where the ham bands are. And we've got, I believe in this, we're green. But we've got little bits here and there, little pieces here and there. And almost all of our little pieces here are shared with other things. By the way, just to let you guys know, this works 3 kilohertz to 30 to or excuse me, 33 kilohertz to 30, 300 to 3 megahertz. So these work by decade, and they also happen to be how the spectrum is broken up: VHF, HF, MF, low F, UHF, SHF. So anyway, this is a handy little chart. But we've got little spots all the way up here into the like almost 300 gigahertz range. As soon as anybody can build a radio that'll work up that high. Unfortunately, we keep losing spectrum down in these areas down here, down in here, where it's really crowded, to 5G cellular and a lot of other people who are willing to pay for spectrum. So ARRL actually has a spectrum defense fund to try and keep our ham radio spectrum. Anyway, now that we know kind of where the frequencies are, I thought it might be handy to know the types of modulation that we use in general. And you'll notice on the beginning, there's many thanks to Wikipedia. I stole a lot of their stuff. So if this top image here is the signal, you can either modulate it with amplitude modulation. And don't worry, Phil, we'll talk about the some of the digital variants a little later. Amplitude modulation, or you can turn the frequency up and down, depending on where you are above and below the center frequency that you're working with, and you get frequency modulation. And that's actually the best picture that I've seen of those. Then we also have other nifty things like phase shift keying, frequency shift keying, which is just shifting between two frequencies, QAM, quadrature amplitude modulation. We can talk about that in detail after the meeting. I'm going to keep the Zoom meeting open so that anybody who wants to talk about these things after and that you may not understand fully, I don't want to bore everyone with it during the meeting, but afterward we could certainly go back to this slide and talk about as many things as we want. DTMF, dual tone multi-frequency, was one of the first digital implementations years ago when they went from rotary dial telephones to touch tone phones. And every button that you push on your touch tone phone, you get two tones. And the frequency is dependent on which row and column you press on the button. And the touch tone pads on your little HF radios use the original DTMF frequencies. And you may think, well, nobody's doing auto patch or anything anymore. But we have Echolink, which is an internet repeater tie-in on one of our repeaters. And you actually use the DTMF to link our 447 repeater to repeaters all over the world. So that's kind of a handy little thing. Anyway, and then of course, other digital modes are direct sequence spread spectrum, chirp spread spectrum. I did some of that work with Qualcomm probably 6-7 years ago. And we also did some frequency hopping spread spectrum. And the chirp stuff was kind of interesting. I know Phil is having a trouble not jumping in all the time here because he's good on this stuff. But the frequency hopping we did at 60 gigahertz with the Peanut Project. Anyway, then I thought we'd talk a little bit about what squelch is. Now, it's very simple. Squelch is simply, we don't want to listen to the hash that's coming in on the background when there's no signal. So the simplest explanation of squelch is just that any level below a certain level, we turn off the audio output. Pretty simple. Now, the thing is that works if you don't have a strong and a weak radio on the same signal. I'll give you an example. There's a really neat tunneling effect from Los Angeles on the coast that heads right down between the marine layer and the ocean. And the 2-meter signal bounces between those two. And if you're sitting on the coast in San Diego at night after the marine layer comes in, you can hear a 146.730 repeater on the same frequency as our repeater, 146.730. So the way you avoid having two repeaters is that you select a frequency below the frequency that you speak at. The minimum frequency that you speak at is 300 hertz. It's 300 to 3 kilohertz for FM HTs and things. So they actually turn on a continuous tone. You have your choice of a whole bunch of different tones between 67 hertz to 254 hertz. And we happen to use 107.2 for our repeaters, which is what we use down here in the San Diego area. And that tone coded squelch signal has to be on in order for the radio to break its squelch and start putting out whatever is coming into it. So it's not only a sufficiently strong signal, but it has to have this tone in there also. And of course, our repeaters are set up to where they won't receive and repeat a signal that doesn't have this CTCSS tone, and they transmit the tone so that if you don't want to hear that other repeater up in Los Angeles on the same frequency, you can set it up to where it only turns on the receiver when that tone code squelch is there. There is another newer system. I don't know of anyone that's using it. It works fine. I've played with it, which is digitally coded squelch, which just sends a very low bit rate of 12 data bits and 11 check bits. Again, it's sub-audible, and it's the same thing as CTCSS, but instead of doing it with tones, you have to match the correct bit code. Then I thought maybe we'd explain a little bit about how much power you're putting out. So they told Stephen Hawking when he did his book, The Brief History of Time, that every time you put in an equation, you half the number of sales. So he only has one equation in his book. It's E equals MC squared. However, I found the book really challenging to read anyway. I had to read chapter 6 about 3 times. Anyway, so these are the only equations I've got, and this is actually the same equation written 2 different ways. This is power out over power in, or voltage out over voltage in. And so, for example, if we're looking at power, 1 watt in gives you 1,000 watts out. So that number, the log base 10 of that, you just count the number of zeros. So it's 3 zeros. So that number is 3 times 10, because it's in decibels, which are 1/10 of a bell. And yes, it was named after Alexander Graham Bell. So 1/10 of a bell. So you got to multiply by 10, and you end up with 30 dB of gain. Now, one of the things that it turns out kind of interesting is that every time you get a power ratio, you change the factor by increasing the power by 10, that you get I want to phrase this differently. By 10, you get a corresponding change of 10 dB. But when you take and you double the power, you get a change of 3 dB. Now, the reason why this is important is everybody thinks, oh, those repeaters up on the mountain, you must be transmitting 500 watts. Well, I can tell you, no, they're actually transmitting 25. It's the antennas that help us out up there. We've got some really nice big antenna arrays, because you can use a lot more power. But if you look at the S meters, 3 dB is only, usually at 6 dB, is only 1 bar on the S meter on your radio. So basically, let's try that again. So basically 4 times the amount of power only gets you 1 bar on your S meter. So power is not the answer to everything. And this I put in for Phil, because I knew he would say, oh, no, that's not right. So anyway, that's the right number. So then I thought maybe we'd talk for a minute or two about antennas. And I found a really good graphic that explains at least the far field for a center fed dipole. So this out here is our radio we're driving a center-fed dipole, and this happens to be a balanced line. So the propagation, and we could end feed this, by the way. Here's the propagation of the electric field that comes off that antenna. And then over here, you can see the field coming out of the antenna. Now, one of the things to note about dipoles is that all of the energy comes out the sides of the dipole. So nothing at all comes out of the top or the bottom. So the envelope of a dipole antenna looks like a donut. There's nothing out of the top or the bottom. It's all coming circular around the sides. So then I wanted to talk a little bit about directional antennas. Actually, the rest of this is the directional antennas. This happens to be an arrow crossed Yagi. I have this little antenna works really well. It's 2 meters with the long elements and 70 centimeters with the short elements. And it's handheld, it's got a little foam rubber grip. And you use it for going out and doing portable satellite work. And there's a lot of little programs that run on your phone that tell you where the amateur radio satellites are located. But what's interesting is if you look in the center here, this is that same little dipole again, feeding it. But what we do is we put a great big reflector behind it to reflect all the energy out the front. And then we put a director on the front to help direct the energy into a tighter beam. And you end up with a pattern like this. That happens to be what is that, a 10 element 2 meter Yagi, which is a pretty nice one. The other antenna is directional and looks similar, has shorter elements, shorter and shorter and shorter. And that's a logarithmic. And what those are for is wide band, where you want to cover a whole lot of bandwidth. So some of these elements interact at different frequencies and others don't. Well, actually, they all interact, but some of them aren't that useful. Anyway, this isn't the last, but this is the last popular antenna, which is the dish. And the nice thing about a dish is the antenna is actually up in this horn. It's about midway up. And usually it's just a little in-fed dipole that's fed from the end. And usually you can rotate it for horizontal or vertical polarization. And what is this? This is just a giant reflector, just like a headlight on a car, that reflects people are leaving. That reflects all of the energy from this large capture area up into this little bitty tiny antenna that's maybe a centimeter long or so, or a couple centimeters long, which is a quarter wave for whatever frequency this thing is designed for. Most of these things were, what were they? They were 4 gigahertz and 12.4 gigahertz for C-band and KU-band TV. Anyway, the nice thing is because it's like a headlight and it's all reflected straight out, you end up with a pattern that looks like this. Basically, this sucker goes like crazy on a single beam. And then if you look, that's odd. There should only be a lobe in one direction on this thing. That may be wrong. Anyway, but this top one is correct. Basically, it fires just like the headlight on a car. Now, there are some interesting ones. I got into playing around with antenna design a few years ago. Satellites, they tend to use circular polarized signals instead of horizontal or vertical. The advantage of the circular polarized signals is that if you transmit a right-hand polarized signal, when it strikes a building or the ground or something, it becomes a left-hand polarized signal when it reflects off of an object. As a result, if you're looking for right-hand polarized signals, your amount of capture of left-hand polarized signals is way down. So it's basically a way of ignoring reflections. So
Comment, Mark.
Sure.
Yeah, I mean, the real reason, that, I mean, that's true, but the real reason that circular polarization is used on satellites is because most of the simpler ones are tumbling. The antennas are turning around. And the neat thing about circular polarization is that, you know, the antenna can rotate and you don't really notice any fading. If you use linear antennas, like you said before, a dipole only radiates in one axis. If you have two cross dipoles, you get no signal. But if it's circular polarized, it can rotate and you don't notice any fading. And then in addition, on top of that, it suppresses multipath that's reflected off the ground.
Well, unfortunately, the only satellites that I deal with were, you know, things like Hubble and large stuff that we don't talk about, and they don't tumble.
Yeah, they don't. But okay, GPS, for example, uses circular polarization, and if it didn't, you know, you would have to rotate your GPS antenna around the vertical axis, and satellites would come and go depending on how you did that. So, for example, for GPS, I mean, there's just no way other than to use circular polarization. So, if you look at this GPS antennas, they have an array of those little corkscrews, just like you're showing there on the left.
You go away.
I'm here.
All right, maybe I'm losing my signal.
Yeah, you were breaking up. So yeah, if you look at a
you guys hear
GPS
me?
antenna, you'll see something that looks a lot like what you
Can
have there on
anyone
the
hear
left.
me?
Yeah, we can hear you fine, Mark.
So go ahead, Mark.
All right, let me try something. I'm getting a broken up signal.
Coming through
All right.
clear on here.
All right, I'm more better now. Anyway, these are some of the more interesting ones. These are helicals. This happens to be a quad helical. Where I played with those, believe it or not, was Vandenberg Air Force Base. And it's just basically 4 helicals phase matched. This one is a really interesting one that I learned about years ago. It's a quadrifilar, which is a wide angle, circular polarized, wide bandwidth antenna. And those are kind of fun. This is what we use up on the mountain, except that the bow tie antenna, or the antennas we use have reflectors behind them, and this is a 4-bay, and this is basically these 4 antennas are set up so that they all receive the same signal, and then they're phase matched. So it's basically like running 4 signals in parallel, so you can get a little bit more out of it. Pardon me? I don't want any talking either. Hello? Is someone talking?
Sorry, I'm muted.
Oh, all right. And finally, this last one is something that I got a chance to play with when I was doing RFID stuff. This is a fractal antenna. And the whole idea with fractal antennas is that you end up with capacitors between each of these little links that are facing each other. And in between the capacitors, you end up with inductors. So you end up with this line that's basically a whole distributed LC network. And what you can do is you can simulate a very large antenna with a physically very small antenna. And of course, you don't get something for nothing, so you pay for it with gain. But you end up with good bandwidth and small size. And the smallest fractal antennas that I've seen for RFID stuff, they're actually putting them inside bottle caps, and they're scanning the bottle caps as they go out through the door to be loaded into a truck, pallet at a time. And I ended up going to fractal antenna systems where they hold the patents on all this stuff, which is how come I knew where to go get that patent from when I was doing this development. A lot of fun stuff to play with. Okay, the last thing I wanted to mention is that you need to connect this stuff. Transmission line is important. Most of us use a good quality coax. This happens to be LMR 400, which is a dual shield. Well, it's actually a foil shield and a braid shield. So it's 100% shielded. Center conductor, it's called an unbalanced line. Unbalanced means the signal comes through the center and the outside is grounded. And then the other one is a balanced line where this is the plus signal, this is the minus signal, and they sit there and they reverse from each other. So this is a differential signal. This is a single non-differential signal. And then for those of you who have to have repeaters and can't afford a lot of loss because you're scrounging for every 1/10 of a dB that you can get, you end up using something by Andrews called Heliax. And this is what's used in most of the commercial radio and television. And even when you start getting up into the microwave stuff, before you start going to waveguide, you end up using this Heliax, which is just a really fancy version of coax. So for those who want to help up on the mountain, and yes, we're kind of looking for, Glenn and I are looking for help. We've kind of lost some of our help. So when you be working on the mountain, we'll be installing Heliax whenever we're running more antenna lines. And we're always working on adding repeaters or adding antennas. Our tower is getting kind of busy, but we're always adding something or other someplace.
I'll add one
Anyway.
comment here, if I can.
Sure.
If you notice that the Andrews Heliax.
Go ahead, Glenn.
On the Heliax, you can tell that it's copper plated aluminum usually for the core, I believe. And that's because of the skin effect. The RF actually travels only on that outer layer of the copper.
I don't know if somebody else can answer. I didn't get that.
It wasn't a
Hello?
question.
He's talking,
What was
Mark.
it?
He's talking.
I think you can go ahead, Mark. I'll stop.
Okay. All right. Is my signal coming through, everyone?
Yeah, we
Yes.
hear you good, Mark. We hear you loud and clear.
Yeah,
Okay,
you're
great.
doing fine.
Thanks, Hank. Thanks, John. Thanks, Hank. All right, I was getting garbled information from Glenn there. All right, so the next thing that we might want to discuss is the difference between, and I realize that most of you guys have been here a long, long time, but I'm hoping to present this to hams who haven't been doing it very long. So it's the difference between simplex and repeaters. This one's from hamradioschool.com. In simplex, both people are transmitting and receiving on the same frequency. And there's nobody in the middle. You transmit on 146.52. When you're done talking, the other guy transmits on 146.52. Now, with a repeater, the disadvantage of this, it's really simple and really clean. The disadvantage with this is when you get more than about 5 miles away, then this doesn't work very well because you end up with stuff in between. Or if it's far enough, just curvature of the earth. In the case of our repeaters, we're at about 5,300 feet up with big antennas facing down towards San Diego, and we're blocked towards Los Angeles. So in our case, we go in on a frequency for 2 meters. It's either 600 kilohertz above or below the receive frequency. And then the repeater, when it gets the correct information, which is that CTCSS tone for an analog repeater that's encrypted underneath the signal, it keys its transmitter on a different frequency, the receive frequency, and anybody can be listening to that. Then when you're done talking, there'll be a little tone saying that the repeater is finished. Then after the tone, you transmit your signal and it comes back, and you can go back and forth and you can cover miles and miles and miles. Our repeaters are on top of Mount Palomar, and we pick up people down in Chula Vista, Tijuana, people out to sea. I've got a problem with one of the trees blocking the shot to the west. So we're gonna have to figure out, I really don't want to cut down trees. You know, I mean, we're in a forest, but we'll have to figure something out, because the little bitty trees that when I started the club were only 3 feet tall are now taller than the 60-foot tower. Anyway, in the old days, the repeaters that we used to have were these wonderful repeaters by Motorola. They came out in like the 1960s and 70s. They're fully transistorized, no ICs, and they were basically designed for organizations like the California Highway Patrol, public services, but it turns out that our 2-meter frequencies are just a skosh below what they were using. So we could retune them and use them for ham radio. Now, what we've done in at least all of our major repeaters is we've replaced those with these new Yaesu digital repeaters, which will do analog and a couple of digital modes also. And so later I'll be showing what the inside of the different repeater buildings looks like with some of these. And then the problem is when you go, I wonder if I can go back. The problem is that when you're transmitting and receiving at the same time, only 600 kilohertz apart, the transmitting radio tends to want to block the signals and make the receiving radio go deaf. So what we do is we have some super finely tuned RF cavities that only pass just the width of the transmitter signal. And we have other cavities that only pass just the width of the received signal on the receiver. And these repeaters actually have 2 inputs. One is for the transmitter and the other was for the receiver. And so there are 2 different sets of these cavities individually tuned. And let me tell you, when you start getting into some of these radios I've got have 6 or 8 cavities on them, tuning these suckers becomes a real nightmare. But you know, it keeps you off the streets and out of the bars. So everybody wants to know where the site is. We don't publish it because I really don't want vandals going up and stealing our coax for the copper value. So there it is. That's exactly where it's at. Wow, everybody was muted. I didn't hear anyone laugh at all.
Oh, yeah.
So there's
job.
the main building. We painted the tops of them white. The sides are all painted kind of a camouflage green. There's the storage building. Battery building is down here. Tower is right there. You can see the reflection or the shadow of the tower here. And these are these, quote, little tiny trees that are as big as the tower now. So that's one of the things we do. Another one is we have a huge vacuum tube bank that we maintain. And the tubes are either, you know, take one, get, you know, leave one, take one, or you know, give us a couple of bucks for a tube just for having, we pay for the storage facility that the tubes are in. So if anybody needs vacuum tubes, we've got tons of them. By the way, just to let you know, Phil, there's a spare disc cone that we're not using also.
Excellent.
Okay, so now we go down to parks, contributions, and equipment, what our club does. This one I took a while back. This antenna right there, that Yagi, that's the one that came down. This is the base of the tower, the analog repeaters, the digital repeaters. This over here is 220 repeaters, and also that's where the digital television station is going to go, but it's not running yet. Here's a couple different shots of the main tower, and you can see where we've got tons of these 4-bay and 8-bay antennas. Here's a shot from the back side. where we've got lots of these 4-bay and 8-bay antennas. There's basically what ends up being a challenge is not having one antenna interfere with another one's patterns. And it's pretty busy, but so far we're doing okay on not having anything bother anything. Now, another thing, we like to say that we're doing emergency services work. Our repeaters are used in times of crisis by the Red Cross and so on and so forth. So we were not lucky enough to get Johnson Controls batteries from AT&T. These were new old stock. They had sat there for 20 years at AT&T. And the rule is if they sit there for 20 years and they've never been used, they must be thrown out. But they were brand new batteries. And these are ultra long life batteries. So there's 24 of these suckers in series. They're about 2.2 volts each. Great big, you can, oh no, this is when it was brand new. There aren't any straps. So here's a wide shot. Yeah, you can see some of the metal straps connecting all these suckers in series. These things are about 1,300 and something amp hours. I'm the one that actually took them all off the trailer like 15 years ago when I was a lot younger, and put them on a little hoist on the back of the pickup. And Mike was hanging, there's a metal beams up here in the ceiling. And we made a little hoist and I would drive the pickup. I had I attached it to the trailer hitch and I'd drive the pickup forward with a 2-to-1 purchase on a little snatch block, lift these things up. Mike pushed them all into place, put little foam spacers, and then we put these metal bars. This thing is all bolted into the floor. It's all bolted everywhere. These, I happen to know because we had to drill that cinder block last week, that is filled cinder block. And we probably have enough power to run our repeaters for a good month, but I'm saying 2 weeks. So if the power goes out, quite frankly, it doesn't make any difference to us. Now, in going into looking into the main analog repeater room, I guess we'll have to paint the floors and make it a little fancier looking. This is an interesting room. It was actually a switching substation from AT&T. So the entire inside of the room is metal screen and grounded. This whole room is a Faraday cage, complete with a grounded screen door. So, I mean, you don't get cell phone very well up there, but if you go into this room and you close the door, you get no external radio signals. So we try and keep it quiet to not bother our repeaters. And I don't know, this is actually kind of a nice place to hang out. Here's one of the repeater racks. This happens to be, I think this is 14673, 447, and on the top is an SCOM repeater controller that allows us to remotely control the repeaters from just, a handheld down in San Diego. And this, by the way, is an FCC requirement. When you've got remote stations like this, you have to be able to remotely control the station, reset it, shut it off. Those are the two main ones, reset it or shut it off. So if you have problems, these little guys, but this is also the one that does the enunciation. It puts the call signs, it puts the voice messages, it puts the courtesy tones at the end of each communications, is all done by these SCOM controllers. So this is one setup. The other setup, this is 2 repeaters. The other setup looks just like this, 2 more repeaters and an SCOM controller.
Can the controller control more than one repeater?
Yes, it can sort of control up to 3, but it's really best to control 2 with it. It's got a 3rd channel, but the 3rd channel is kind of lame. So it's best to control 2 repeaters with it, and that's what we do with them. And then this is a little touch screen on the Yaesu for setting up, transmit frequency, receive frequency, CTCSS tones, what modes it's going to accept. All the stuff associated with a repeater. Now, we do host other clubs. This was ECRA, the East County Repeater Association. They lost their site. They don't have a lot of money like our club. Their funds, they're worse off than we are. They don't have much. So we agreed to host them for just a nominal fee. And right now, the board members are actually paying that nominal yearly fee out of their own pockets because the club's broke. But this is their old repeater system. It's some old Yaesus. And the thing generates a lot of noise. So I've been clamping ferrites trying to quiet this thing down for months, but I think I've got it pretty well under control now. But we do help other people. We've also, in the other building, got several 220 repeaters for the Mexican Radio Club and also the Convair 6 shooters. And these were donated by Michelle. And these are a beautiful set of pre-tuned 6-meter cavities that are just gorgeous. However, they are longer than the building is tall. So we had to build a little shelf here and take ropes and tie them up there so that we could put them into the building. But those are the neatest cans that we've got. I should say filters, tuned cavity filters. This I wanted to put a picture of because not many people that aren't hams, boy, there's a quadruple negative. They've never seen these before. I hadn't seen them till I started working with radio. This is a magnetic recirculator. Basically, you put a signal from the repeater or from the radio transmitting through this thing and then out. This is a filter, by the way, and out towards the antenna here. And what happens is if we get RF reflecting, let's say a high SWR, which I didn't cover here, when you get a high SWR and you get energy reflected, this circulator actually diverts that energy, and instead of going back into the radio and heating up the finals, that energy goes out into this 50 ohm load. So you never have energy going back into your radio. Now, like all things in the world, this is not free. There's insertion loss. It messes up your SWR just a little bit. We'll just call it an insurance policy. But since most people have never seen a circulator before, I thought I'd show a picture of one. Also, you can see the wall of that building where it's metal screen with a 6-inch copper sheet going all the way around the building. And I have tied all of the grounds, although you can't see them. I've tied all the grounds for everything into this copper sheet all the way around. Now, another thing, when you're at 5,300 feet up and you've got a 60-foot metal spike in the air, you are going to attract lightning. So I yanked this one out of service. This is mounted in the floor of the building where all of the pass-throughs are at. And this is a lightning suppressor. Basically what it's got is a gas-filled spark gap, so that if we get any high energy spikes, like lightning strike on the tower or nearby, it will come in here, go through the spark gap and ground to the outside of this thing and into the structure of our building, rather than going up into our radios and blowing our receivers apart. So I figure most people hadn't seen lightning spark gaps like that before. So I put a picture in there. As I said, we run everything on 48 volts. And since all these ham radio repeaters all run on actually 13.8, they're designed for car batteries. These are the incoming 48 volts coming in and 12 volts going out. And then since we needed to know what power supply was what, these power supplies are big enough that they could actually run 25 amps. They could run 2 repeaters pretty well. Most of the repeaters have their own individual power supplies. These supplies were selected before I took this back over again, and I didn't mess with them. They're not the most efficient supplies, but they have been super reliable, and they don't generate any RF noise. Switching power supplies generate RF. These guys are really quiet. So using the time-tested technique of if it ain't broke, don't fix it, I've stayed with these supplies and they're great. They're all, I've got them all over the place in there for all the different radios. Now, there is another room, a separate building with the digital repeaters in it. These are the digital repeaters here. And they are the older Motorola repeaters. They are still running like a champ. And that room is kind of interesting because it's actually below ground. So once you open the door, you've got a few steps down to get into that building. And I made the foolhardy mistake of actually dropping something and it rolled underneath those steps. And that became a really interesting thing to try and get that out of there. But anyway, once again, you can see insulation, RF tight. This uses a door that's like an equipment rack. It's an RF tight door. So again, neat design. Now, for those of us, probably the most important item on the mountain for all of us slaves up there working, there's only a few of us now, is we got a picnic bench. When you get tired, you can go sit at the picnic table. That picnic table, I've been doing this for like almost 20 years with the club. And that picnic table was there before I was. Nobody's taken it. And boy, that's the most important thing we've got. I don't have, well, I actually have pictures of us taking breaks there, but I figured that, you know, I'd limit it. Anyway, last year, or not, excuse me, not last year, year before, we had a cleanup. Everybody is wearing masks. This was before COVID. They're wearing masks because I brought my shredder up. And to get the amount of bags that we took off the mountain down the hill. And we generated so much dust that everybody had to wear masks just because of all the mess we were cleaning up. But we got all the leaves off the ground. We trimmed branches. We fed branches through that beast. We did pretty much everything. We also made good use of the picnic table. We ended up with a entire long bed dually pickup filled to capacity with trash bags, shredded. So they probably, the trash bags probably, what do you think, Glenn? They weighed probably 75 to 90 pounds per trash bag. And we had a whole pickup load full of them.
Not that heavy, but we also had most of my trailer full too. It took me several weeks to get rid of it through the city trash.
Yeah, you guys heard that.
And I had my truck full too.
Anyway,
so we got a lot of them.
All right. Anyway, so this was a cleanup, club cleanup. We are going to do another one. Although I got to tell you guys, after we raked all those leaves and everything, it's still not too bad, even to this day. So, but we're going to do a cleanup. We're going to go up. I've replaced my gasoline, because you're always worried about sparks where I live. I've replaced my gas-powered gardening equipment with electric. So the only thing gas-powered is going to be this big shredder It's got a spark arrestor, and Glenn's got a fire extinguisher. So we'll go up and we'll probably do this game again after everybody gets inoculated and we're in good shape. We're not in too bad a shape now. That's a picture of that pole that Glenn and I put up last weekend. These are 1/2 inch, you know, you got to build things up there to withstand snow. These are 1/2 inch studs driven about 5 inches into an 8-inch thick filled cinder block wall. So that thing, you know, you could climb up that with no, you might bend the pole, but you won't pull those things out of that cinder block wall. They're in there good. And we've got a storage container for storing everything. We've got some spare power sections. We do have equipment that we can loan out to club members. So, and a lot of it's in this storage container, plus all of our parts and tools and everything that we use up there. This is a recent picture. You can see what the leaves are like now. They're not too bad. They could use a little bit of work, but not overwhelming. We don't have a 2-inch thick bed of leaves anymore. Every once in a while, we do have people that have to go up and work on the tower, and everybody's always trying to get pictures. Meanwhile, in the dead of winter, one of our problems is that our tower ices over. One of the reasons why we have to repair things is our tower gets icicles on it, and the icicles add a lot of wind load. And as a result, we end up breaking things, such as that 2-meter antenna that broke right in the middle there. You can see where the pole broke. That thing filled with ice. The wind got it, broke it off. And it's a beautiful little antenna. And you can see we bent the front element, but other than that, it's in pretty good shape. So I think it's not being used right now, but I think we're going to put it back up anyway. We're going to be doing some additional capability, and it wouldn't hurt to have a 2-meter antenna completely separate from our repeater network for what we're planning. Phil. Anyway, yeah. Last trip up, when this is my car up there. Last trip up, we didn't have too much snow. I don't go up when the snow is, you know, feet thick, but it does get a fair amount of snow up there. So, and that's what makes it a little challenging for us. Now, as far as future efforts that the club is sponsoring, we already have Echolink. For those of you who don't know what Echolink is, it's a repeater intertie system through the internet that allows you to link repeaters together anywhere in the world. And our UHF repeater 447 is on Echolink. You use your little DTMF keypad, you get on 447. There's a list of repeaters all over the world. You key in, it's usually a 5-digit code. You key in the 5-digit code, and then you'll hear the voice saying that it's linked. And then all of a sudden, you're not only in San Diego County, but you're in Australia or Dallas, Texas, or Tokyo, Japan, or wherever you want to hook your repeater up to.
Add something there?
Yeah, please, go ahead.
So also, there is an app you can install on your cell phone. You go voice over IP to the Echolink node, and then you go out on the 447 repeater. Or you can connect from Echolink.
Can anyone else hear Glenn? I'm not getting him.
Yeah, he sounds great.
Okay, it's just my incoming then. Great.
Yeah, but
okay, was that it, Glenn?
Mark, do you need a relay?
Yeah, the incoming is distorted. I must not have enough bandwidth coming in.
That was it, Mark.
Anyway, I know one thing that'll help me. Quit transmitting video, that might help. All right. Anyway, another digital standard is Wires X. I had that up and running last year, and then the computer blew a hard drive. It was a pretty high performance computer, took out a hard drive. So I'm replacing it with a much simpler, cheaper computer. And John, you don't have to say anything. Joe, I know I'm remiss in getting it back online again. If it helps, I'm sitting here looking at it, if that makes you feel any better.
We
So
love
I
you,
will
Mark.
be-
Don't worry about it.
I will be putting Wires X back on 147.075 again.
Good.
But right now, what I'm working on is getting a full-on internet connection up on the mountain. And thank goodness, I know the owner who owns the ISP, the internet service provider up here. And I gave him the story about how we do public service work and how we, and I showed him the battery bank, and we're going to put him on the battery backed up system. So he's not going through any of his repeaters. He's got a big battery backup system at his main site. So it looks like he'll stay up. If the power goes down, he can stay up at least a couple of days. So we won't lose our internet, at least for a few days. Our site will run a lot longer than his. And once we get internet up on the mountain, I've already talked to Phil about software-defined radios up there. And Charlie has, NN3V, has graciously agreed to help out any way he can on what he refers to as digitization of the club. And quite frankly, the sky's the limit here. I'm going to have 10 megabits per second synchronous data rates up and down. So, and he's pretty good about, it doesn't drop to 1 megabit per second while everybody's watching TV at night. It pretty much stays where it should. Anyway, I've been talking for 45 minutes-ish. Any questions?
Hey, Mark, I just want to say that was awesome, and I really enjoyed to see all those photos. So thank you so much. That was really cool.
Great. I got the end of that, Hank. Apparently, I'm having a lot of incoming problems tonight.
This is John. Can you copy me?
Yeah, it's broken up. Let me try something. Let me switch the audio.
I'll just send you an email
to a different source. This is a new device. Okay, try it now.
Yeah, can you copy me now?
It's a little more intelligible.
Okay, I'll send you an email. Thanks so much for that great presentation. I sure appreciate it.
Yeah, this is KK6FRK. Can you copy me? Over.
Sorry, go ahead, Keith.
Yeah, this is Kevin. Am I readable?
Oh, I'm sorry, Kevin.
That's all right. Am I readable?
Yeah, you're perfect now.
Okay, outstanding. Yeah, what I was going to suggest, and this can be discussed more at the board meeting, and I'll try to parachute into the board meeting next Wednesday, is if when we're looking at these goals and objectives is to divide up small projects and then identify the tasking and the skills and knowledge necessary and say, this is how you as a club member can participate. You can help with this particular area of tasking, and this is the skills and knowledge that we anticipate that would be required. That way, people will have the opportunity to get involved. Back to you.
Very good. Well, can you hear me? Yes, I guess you can. One of the things, Kevin, is if you want to take the first half of this, which is now going to be on YouTube, and we do a general explanation of radios and repeaters and simplex and modulation and that stuff. If you want to use that for anything, be my guest. It was intended to be something to help people who weren't familiar with VHF, UHF. And unfortunately, just looking at the faces out there, most of you guys, you know, you've been around for a lot of years and you know what's going on. But so anyway,
Yeah,
feel
thanks.
free to share it with anybody who's new.
Yeah, I would definitely do that. Your earlier material for the first, excuse me, 20 minutes or so was a great tutorial. What I was referring to in terms of getting club member involvement is the things that you're planning up on the mountain and things, prep work that people may be able to do prior to going up on the mountain, associated with what Charlie has called the digitization. It's kind of really the networking of our gear, so that it's kind of in line with what we are forced to do with Zoom, where we have telepresent command and control of amateur radio equipment. So back to you.
Well, yes, that's actually something that we're looking at doing, is allowing more control. The SWRs, you'll be able to remotely control what they do once they're set up. And of course, like I said, we've got Echo Link, so you can get on 447 and you can tie that repeater anywhere in the world. Once I get 075 Wires X, you'll be able to tie that to all of Yaesu's Wires X network everywhere in the world. So yeah, we're gonna be capable of linking these repeaters.
Right.
Some we can do now. One we can do now. We'll be able to do another one as soon as I get Wires X back.
Well, far out. I liked everything that you presented. I like the way you're laying out milestones for a way forward. So thanks again. Back to you.
Okay, we got a Bob said, what's the time limit on using Echolink? To be honest with you, I don't know. I've got the Echolink manual. And I think you can, as long as it's active, it remains linked for, I don't know how long it'll remain linked, as long as there's communications. When you let it go dormant, it drops the link after maybe 3 to 5 minutes.
That sounds about right.
It drops the link.
So I have a question about Echolink.
Sure.
So the whole idea behind Echolink, at least on a very basic surface level, is I am remote somewhere and want to talk to my local amateur radio buddies on the park repeater. Has the board considered potentially moving Echolink to a frequency that's more widely utilized? Because it seems to me the 440s dead in Southern California. I mean, all our repeaters are dead, unfortunately, but the whole idea behind Echolink is I want to talk to someone local. No one's on 440. It's never going to get used.
Well, that's actually one of the advantages, is that you're not going to be breaking up other communications. If you know that you want to talk to somebody, just have them get on 447 and then you get in with Echolink. By the way, one of the ways Glenn and I were testing Echolink, there's an Echolink app for your phone. And once they verify that, yea, verily, you are a licensed amateur, they enable the Echolink app and you can get on your phone and talk to the repeater from a remote, from a remote location.
Or any of the repeaters that are Echolink nodes worldwide.
Yeah, any of them.
I can answer part of that, Mark, for Greg. So part of the issue there is that we don't want to double up on remote capabilities. I think we've decided that we don't want anything remotely on 146.7.3, because that's kind of like the primary machine that the few people that monitor on a regular basis are on. And the correct me if I'm wrong, Mark, Wires X is going on the 130?
No, 075.
075. Okay. And then the 130, that one is reserved for, like, that's kind of sort of emergency, so we're not going to do anything remote on that. Was that right?
Or if I do, it will be if I do, it will be the last one to be activated.
Okay.
I think one comment, Greg, on the 447 is in playing around with supposed dual band antennas that are 440 and 2 meter and 70 centimeters. They don't work very good on 70 centimeters unless they're really designed to cover it, because it's not a true 3-to-1 odd multiple of the base 2 meter frequency band.
Yeah, well, for dipoles, you're right. What you do is you shove a coil in the thing and you pretend for 70 centimeter like part of it isn't there, or you put a coil in the middle and you try and make it act like a collinear. But obviously up on the mountain, we actually have designated 440 antennas that are designed for 440. And then the Yagi that I have actually just has a 2 meter Yagi and a 4 meter and a 440 Yagi mounted on the same pole. Someone just said, "Thanks for the great update and pictures. Have you ever painted the picnic table?" Not that I am aware of in the last 20 years.
Paint it.
Needs it.
I will say it definitely has character.
Question.
Sure.
It's a follow-up to the question I asked earlier about time limit. I didn't phrase it very well. What I meant was, as a user of Echolink, I assume we should be practical and limit. In other words, we don't want to get into a conversation with somebody in Australia and talk for 30 or 40 minutes. We should limit it to what, 15 minutes, 10 minutes, something like that. No long
Okay.
rags.
In the old days, before everybody had a cell phone in your pocket, then you would say, yeah, maybe it doesn't make any sense to rag chew over Echolink where you've got two repeaters tied together. But you know something? Sometimes I'll flip on the monitor speakers when I'm up there working, and I'll work for 3, 4, 5 hours and never hear any of the repeaters come up at all.
Mm.
So I wouldn't worry too much about overutilizing the resources unless there is an emergency, an earthquake, major fires, that kind of thing. And of course, everybody has enough wherewithal that, when the Red Cross gets in there and says, we got to move blood from this hospital to this hospital, all the rag chewers get off the air and let them pass their emergency traffic. But other than that, the repeaters never get used. That's one of the reasons why I asked to do this presentation tonight, because the repeaters are always quiet and they're sitting up there, they're running. We pay the electric bills. We own the property,
Where's
Doug's
everybody
saying,
at?
I think the old days are over. Yeah, Doug, you're right. The old days are over. But all that equipment's up there and it all works. And I sure wish somebody would start using it. Meanwhile, the only thing I can do is we take funds and time that are donated by the club members, and I just keep making it better and better, maintaining it, working on the site, trying to make everything more plausible. One of the main subjects in our board meetings is how to attract people, an interest in doing this, and how do we retain members, and how do we get the repeaters to start being used? Are there any other questions, comments?
Well, I guess one way to get our repeaters used is to try to make the service a little bit more like Zoom. Zoom certainly gets used. And by that, I
The
mean,
problem with that is you can't do business over ham radio.
well, no. I mean, for ham radio clubs, we could certainly have this meeting on the air. I mean, there's nothing says we can't. The problem with repeaters is, they're full duplex. It's just not the same kind of style of conversation that you have when you're face to face or even here, when you can interrupt each other and two people can talk at once and you're both at the same time. And that's basically what I've been working on is, how do we do that? Originally in a satellite context, but I'd like to do a trial on the ground. I think it can work here too. And that's the basis of what I want to put up on the mountain. Everybody transmits on a separate channel or a channel that you pick at random from a large list so that you're not likely to collide. And then you hear everybody come down at the same time. So it's a little bit more like Zoom. I mean, maybe people are tired of Zoom by now, but I think it's still an interesting thing to try.
Yeah, that'd be interesting. Where everybody goes in on their own frequency, and then the mountain comes down on a single frequency.
Yeah, and we can start this, in phases. I mean, initially, it'll come down on the internet, and everybody can just listen to the internet feed. But eventually, we'll have a high-speed digital transmitter up there, which will bring it down, independent of the internet. I mean, Echolink is nice, but we're tying ourselves to the internet. It's fun for Rag2 and experimentation, but if you're serious about emergency communications, you can't rely on it.
This is AJ6IT with a comment.
Yeah,
go ahead, Steve.
Yeah, I was going to say, so the repeater 145.280, that's the W6ZN repeater. They have mastered what you're looking to do. They have multiple inputs. And I don't know anything about their inputs. These guys are very, very smart in what they do. But yes, they have multiple inputs and can actually have 4 or 5 people talking at the same time.
Oh, I actually didn't know. I mean, that's one of the more popular repeaters that I've been monitoring because I can basically watch everything on a band at once. And I actually didn't know they could do that.
I thought it was odd. I mean, I've listened to them quite often, and to the amount of voice and the interaction, the quickness with which they respond to each other has been amazing. So I assumed they had something unusual.
Well, the other place where I
W6ZN, he's a former DJ in San Diego.
Yeah.
Okay.
So, yeah, I think they got a pretty good setup there for making it sound more like radio. They do trivia on Monday nights, and that's when it. Really
oh yeah, I've heard that. That's actually interesting. It's fun to listen to.
Yeah, I participate in that one. I like it a lot.
Yeah. I had thought that repeaters that do that sort of thing. One guy's on Echolink, another guy's on a 2-meter input, another guy's on a 70 centimeter, something like that. I thought that's how they do it.
Yeah, there's multiple inputs is what they're using. And
yeah, I mean a small number of inputs. Like one on each band or something like that. One, I mean, that's the way link repeaters usually work. Here, though, I mean, I want to scale this up. I want to have a large number of channels where you can have a whole group of people like what we have here, and then everybody just picks a channel. And I mean, you don't have to transmit it all the time, but the point is you could pick up your mic button and transmit, and you won't collide with somebody else. And if you happen to talk at the same time as someone else, then the people listening will hear both voices at once.
Exactly. Yeah, it's pretty cool how they have their setup.
Yeah.
So yeah, that was my question, comment, and a very good presentation, by the way. Maybe I can, if I have a lot of vacation time available, maybe midweek or something, if you guys are going up on the mountain, I'd like to come up and at least take a tour, see what you got, and I got some skills I can help out and anything like that.
Just don't go up in a snow.
Send me an email at kf6wtn@gmail. And Glenn and I are going to be going up when the ISP mounts the dish in the next couple of days.
Okay. Yeah, I'll
probably Friday.
Excuse me?
Probably Friday.
Oh, that's in 2 days. I probably won't be able to then. It's kind of busy for us, but I can in the future. I can definitely, if you have a future date, I can could definitely get this time scheduled off.
Okay.
All right.
Well, thank you.
Good. Well, I think from Kevin's comment earlier, I think one of his about getting was a methodology or process that we as a club have to say, we have these tasks that, or this task that needs to be done. Here's what we think, and just who in the club would be willing to step in and do that, so that it's like running a volunteer business, where here's the task, you can do it, you can't do it, you want to do it, you want to help, you're willing to watch, that kind of thing, to bring participation more and get more coverage for the work that needs to be done. So good idea, Kevin.
All right, well, it's 9 o'clock. I haven't looked to see how many people are there. I could stop sharing. Oh, we still have a good sized crowd.
24 people still.
Yeah. Anyway, I do want to say one last time that the first half of this was on radios, and if you want to present this, on YouTube, send it to New Hams. I don't mind the advertising, and not once did I mention the club's call sign. And by the way, I don't know if you guys are aware of the monikers, that where you take the last 3 letters and you try and make up additional phonetics. Our club is W6NWG, which is nothing works good.
Let's drop that one.
You don't like that one?
No.
Well, that's okay. You and I keep working our butts off trying to make it work good.
We'll change it. Now working great.
Well,
Beautiful, Glenn.
You gotta change the N. Works good is fine. We gotta find another word for N other than nothing.
The word now.
Yeah.
Now it works good.
Great.
Yeah, there we go.
Thanks, John.
All right. So anyway, guys, all I can say is anyone willing to distribute this, and let new people understand, please do. I want more people. I'd like to be up there and at least hear the repeaters operate every once in a while.
Mark, can you let me share my screen for a minute?
Yeah, go for it. You can.
I can? Okay. All right. Make sure I have the right one here. I think this is the right one.
So are we calling the meeting itself is closed, and this is post-meeting?
Yeah. Do you want to close the meeting, Joe?
Oh yeah. So thank you again for everybody coming out, and for Mark and all of the other input on our functionality. Our May program is going to be K8Z Tango. Anthony talking about field day and what it might look like for Park to do field day. So
I saved one power and a set of antennas and rotators.
Thanks, Mark.
Okay, I'm going to shut off the live stream now.